Okay, so today we're going to be calibrating an MENE008 120 volt proportional control actuator. This is an 800 inch-pound actuator set up for 4 to 20 milliamp input and feedback, direct acting. The actuator is mounted on top of a 2-inch 3-piece stainless ball valve, and we're going to go through and do all the entire set of calibration on this unit. So on the main PC board, this has got a couple of settings you want to take a look at. There's a dip switch setting here. There's an 8-position dip switch, and this dip switch is detailed on the wiring diagram, and it shows you what all the various dip switches are. And I show here what's the default setting. It's 4 to 20, and your dip switch settings for switches 1 through 5 control your input and your feedback. Switch 6 is set for direct acting, and then 7 and 8 set your loss of signal. The default setting is to fail clockwise if you lose your analog signal. So that's all your settings for your 8-position dip switch. Then we also have 4 buttons to program here. This is a little bit more intelligent than the A, B, C frame units in that you don't have to trim potentiometers for your analog response to calibrate it to your signal. These 4 buttons will calibrate the actuator between the 2 end of travel cams after the cams have been set. And then the LED indicators here tell you what the status is on the lights. So right now I've got the power off on this actuator. This is an analog signal transducer. It generates a 4 to 20 signal out, and it also reads a 4 to 20 signal back in, tells me what the feedback on the actuator is doing in response to the mechanical positioning. So what we're going to do is I've got this set for, I'm going to drop this down to 50%. That's a 12 milliamp signal. And I'm going to go ahead and power this up, and what should happen is the actuator should move from a full open position and travel to 50% closed in a clockwise direction. The indicator shaft and the cams are connected to the camshaft, which is directly connected to the mechanical output. So whatever is happening on the output of the actuator on the bottom is the exact same thing that you see from above. And this is a standard max air electric actuator in that the actuator rotates clockwise to close the valve. All the valve assemblies are done the same way. So I'll go ahead and power up the actuator. It'll enable the control board. And the unit, since it's getting a 12 milliamp signal, should drive to about 50%. And there it has. So we're seeing 12.1 milliamps on the feedback. If we look at the bore on the valve, we see that the valve is roughly 50% open. So we're going to go ahead and generate a 20 milliamp signal to test the full open position on the actuator. I'll set it to 20 milliamps, and we're going to see this unit run counterclockwise going in the open direction. And so what we have, the travel cams stop the actuator. We have a 20 milliamp signal coming in, and we're showing 19.6 milliamps on the feedback. If I check the output position of the actuator, you can see that the ball is just a little bit short of being in the full open position. So what I'm going to do is I'm going to adjust that. First thing I'm going to do is take the power off the actuator. And then on these epicyclic type gear trains, on the E008 and larger, we actually have mechanical stops. And the purpose of these stops is to prevent over travel when you're using the hand wheel on the actuator. The one thing you don't want to do on an electric actuator is to run the gear train into the mechanical stops. That will damage the actuator. So as this has left the factory, it's already been pre-calibrated, but to show this proper sequence, the first thing you do when you're adjusting any of the cams on the E008 and larger is we're going to back the set screw, the mechanical stop screws, we're going to back these out from the actuator a couple of turns and get them out of the way of any adjustments that we're making with the cams. So we'll back those out a couple of turns. Now I'm going to use the hand wheel, and I'm going to rotate. Since I want the valve to go open just a little bit further, I'm going to rotate the hand wheel in a counterclockwise direction and drive this until I can see the ball exactly where I want it. And there we go. So now the valve mechanically is in the correct position on the open cam. So before I turn the power back on, because if I did, the actuator would go back to the position where it was. And what I want to do is I want to set it up to be recalibrated. So in looking at the wiring diagram shows that our open travel cam is the number one cam. That's the bottom of the stack, the number one cam. That's the one that we want to adjust for the open position. So I'm going to use a 2.5 millimeter hex key. And what happens here is in looking at the direction of how the camshaft operates, when the actuator is operating, remember we're going in a counterclockwise direction. So what I need to do is stop the actuator later, which means if the cam is rotating to the right, if I retard that cam position a little bit to the left, it has to travel further before it stops again. So I'm going to go in with a 2.5 millimeter set screw, and I need to move the cam so that it trips the actuator a little bit later, since it's going in a counterclockwise direction. If I move the cam to the right, it would stop sooner. I want to move it to the left. So I'm going to loosen this up and swing it to the left, and I can hear the switch clicking. So what I'm going to do is move it so that I'm off cam, snug it up just a little bit, and then pull it until I hear that switch click. And then I'm going to tighten it down, just snug it up. So now the actuator is going to stop on the cam in the full open position. Okay? So the next thing I'm going to do is I'm going to turn the power back on, and I'm going to do the same thing for the clockwise cam in the closed position. So I'm going to power this up, and I'm going to set the input for 4 milliamps. And you'll see the cam, the whole camshaft, all the switches, the feedback pot, the position indicator, and the valve are all moving clockwise in a closed direction. And so it's stopped on the electrical travel. I'm going to look at the valve and confirm that it actually is in the fully closed position. If I was going to adjust this, since this is looking at the wiring diagram, the counterclockwise position is the number 2 cam. Number 2 is the red cam controlling clockwise positioning. So in a clockwise position, the camshaft and the indicator and everything is turning clockwise. So the logic is if you've got a cam sitting here and you turn it that way, it's going to stop sooner. If you go to the right, it has to travel further. So if I was going to want to go further, I would move the cam to the right. If I wanted it to stop sooner, I would move the cam to the left. This unit happens to be calibrated exactly where we need it to as far as the analog signal response. So at this point, what I'm going to do is we've got the 2 travel cams established. I'm going to rotate this around with the power still on it. And I'm going to press the set button, which is the bottom left corner, for 2 seconds. And what that does is it sets this board to do a programming of the positioning between those 2 cams. Now I'm going to hold the up button, which is the bottom right. I'm going to hold that until we get to a full open position. And I don't have to look at the valve anymore because we set the cam to be in the right place. Okay, I'm in the full open position. I'm going to send it a 20 milliamp, 100% signal. At this point, I'm going to press the mode switch and hold it down for 2 seconds. And we're good. We've now set the full open position. Okay, now I'm going to go to the down button, which is the upper right-hand corner here, and I'm going to run this until it runs into the end of travel cam in a clockwise direction for full closed. So the actuator is running closed, valve is closing, running in a clockwise direction. I'm going to hold the down button in till it stops. And it's in this full stop position. I'm going to send it a 4 milliamp signal, and I'm going to hit mode and hold it down for 2 seconds. We're good. And the last thing I'm going to do is check the calibration at the full close position to make sure the feedback is sitting at 4 milliamps, and I can see that it is in fact sitting exactly at 4 milliamps, which makes sense. It's microprocessor controlled. If it was off at all, you would come in here and adjust VR2 one way or the other while you're watching your feedback to make sure that you get it set exactly where you want it to set. Once you get to that point and everything looks good, you're going to hold the set button down, and it will leave the setting mode. And there we're good. So now the actuator is set mechanically to run the valve open and closed. It's set electronically between the two cams, and the microcontroller board is programmed both in analog signal response and feedback for going between the cams for 0 and 90 degrees. Okay, so at this point what I'm going to do is I'm going to send it a 100% signal, and we should see it run counterclockwise to go fully closed. Fully open, excuse me. You see the feedback increasing. Okay, and we're now roughly 19.9 milliamps. There is no calibration on the full open side, 19.9 for the full open. Now what I'm going to do, since we know that's where it stopped in the open direction running counterclockwise, is I'm going to go in and adjust the mechanical stop to find out where the boss is inside on the gear train to where the end of travel is. And we've hit that end of travel right there. I'm going to take this and back it down 3/4 of a turn, and then come over here and lock the jam nut into position so it'll lock it in. And we're good there. And what that does is it prevents the hand wheel from rotating further than it's supposed to, and moving it back that 3/4 of a turn gets the mechanical stop away from the motor-driven electrical part of the actuator. All right, the next thing I'm going to do before I move off the full open position is I'm going to go in here and adjust the number 3 cam, and I can watch what's going on here. I'm trying to do this so it's easier to see without getting... And I'm going to loosen this up, and then I can adjust when that cam actually trips. So moving counterclockwise, remember in the open position we're going counterclockwise, so the cam is going to approach the switch from the left going to the right. When you see it trip, and go just a little bit further, and that's where it's set. Now the auxiliary switch is set. Good to go. Let's go ahead and send it a 4 milliamp signal. We're driving in a clockwise direction. You can see the auxiliary switch is already tripped, but if we were going to calibrate that, this is the top red cam. This would approach the switch from the left side. So we can move it this way and then pull it to the left until it trips, and then just a little bit more. Now we're fully calibrated on the mechanical stops. Oh, sorry. We're in the full close position. At this point, we can go in and adjust this one, the right side, for the closed position. Remember, the actuator is running clockwise to close. So that means the gear train is running this way. It's going up against a mechanical stop inside the gear train. So we're going to run this in through, and there's the mechanical stop. I'm going to back off 3/4 of a turn, lock the jam nut, and we're good. Keep in mind that these are just there's no torque required on these things. You don't have to really tighten this down to the point where you're squishing the sealing washer. There's no reason to do that. It's the same thing for the travel cam, the 2.5mm hex key. If you ever get to the point where you see your hex key is twisting, you're tightening them way too tight, and it does not have to be done that way. So now we're fully calibrated. We've checked the mechanical stops in the open position, the closed position. We've checked the response to the analog signal input. We've checked the analog signal output, and we've checked the auxiliary switches. This unit is fully calibrated and is ready to be put into service. And as always, don't lick the wires.